Hey everybody, Jake here coming at you with another live math lesson this Monday night, 5 o'clock Pacific time, 8 o'clock Eastern. Tonight is Monday, January 23rd, 2023. Today we're going to be talking about finding zeros of polynomial functions. I'm going to be going through a few specific examples showing you exactly how to find this. The examples we're going to go through are going to be quadratics specifically, which is a type of a polynomial. But I'm definitely going to touch on how you can kind of apply these same methods to find the zeros of any polynomial that you might run into. It is going to be, sort of a similar process, similar idea at least. The steps may be a little bit different for other types of polynomials, but the kind of general strategy and general things that you want to be thinking about are going to be the same either way. So I'll definitely touch on how that applies to kind of the expanded version of other polynomials. So let's just go ahead and jump on into it here. As always with these live streams, if you do have any questions along the way, feel free to throw them in the live chat. I'm happy to help answer any questions that you have as we go, whether it's on topic or off topic. I'm happy to help. I may not be able to answer any off topic question, but I'll do my best. So throw those in the live comments and we'll go from there. But let's go ahead and get started with this problem here. Find all the real zeros of the polynomial function, and the function that we got here is f of x equals 49 minus x squared. So really, when it comes to any of these types of problems where you're trying to find all the real zeros of the polynomial, really what that means is essentially all you're doing is you're taking the function that they give you, 49 minus x squared in this case, and setting it equal to 0. And whatever x values solve this equation, when you set it equal to 0, that would be a 0 of the function or a 0 of the equation. So this is really all you're doing with any of these finding the zeros of a polynomial. You just set the polynomial equal to 0 and solve for x. That's really all it is. So there's a couple different approaches you could take. In general, if you ever have a quadratic or any polynomial equal to 0, the best approach is to try and factor it. Now, you may not necessarily always be able to factor any quadratic or any polynomial, but if you can, that's probably going to be your best bet. So let's talk about how to factor this one specifically. It's a little bit weird because we don't have an x term, right? We just have an x squared term and a constant term. So it doesn't exactly look like a lot of quadratics. But what we have here, which is kind of nice, is when you don't have that x term, what you can look for sometimes is to see if you can apply difference of squares, which in this case we can. So difference of squares basically just says if you have one term that is a square minus another term that is a square, you can factor that out into the first term plus the square root of the first term plus the square root of the second term times the square root of the first term minus the square root of the second term. So in this case, in order to apply this difference of squares formula, all we want to do is think of 49 minus x squared as 7 squared minus x squared equals 0. Because now we have two square things being minus from each other, one minus the other one. So we can directly apply this difference of squares formula and just take the square root of the first term. The square root of 7 squared is 7. So 7 plus the square root of the second term. The square root of x squared is just x. And then 7 minus x equals 0. And the reason why you want to try and factor a polynomial when you're looking for zeros is because when you have the product of multiple things and you know that product has to equal 0, well, that's going to happen whenever any one of these factors equals 0, right? If this term is 0 and this term is not, you still end up with 0 times some other number. Similarly, if this second term is 0 and the first one is not, you still end up with some number times 0. And anything times 0 is 0. So as long as either one of these terms is 0, the whole equation as a whole would be 0. So really what that allows you to do is kind of split this into two separate equations that are easier to solve and kind of create a list of different x values that solve any one of the multiple equations and that gives you all the x values that would cause this whole thing to be 0. So basically we can say 7 plus x equals 0, solve that equation, and then 7 minus x equals 0, and solve that equation. Solving this one, we would just subtract 7 from both sides, giving us x equals -7. For this one, we can just add x to both sides, giving us 7 equals x. So if x equals +7 or x equals -7, the equation as a whole, the original equation, is going to equal 0, meaning x equals 7 and x equals -7 are the zeros of this original function that we had. So you really want to try factoring if you can. That's going to be kind of the easiest way to find zeros of a polynomial. Now, there are other methods, and I will get into what those other methods are, or at least one of those other methods, here shortly, but that was just kind of a good example of factoring, specifically using difference of squares that can be kind of nice. So let's go ahead and get into this next example here. Again, same type of problem. Find all the real zeros of the polynomial function. This time the function that we have is f of x equals x squared plus 10x minus 20, or plus 25, I'm sorry. So let's go ahead and talk about another way that we can find the zeros of this function besides factoring. Now, still the thing that you want to keep in mind, if you're ever trying to find the real zeros of a polynomial, that means that you want to take the whole equation and set it equal to 0. So it's the same approach whether you're going to be factoring or not. That's all finding the zeros of a function in general means, is that you take your function, set it to 0, solve for x. That's really the approach. You know, how you actually solve for x is kind of where the different variations of ways that you can solve the problem come into play. Or also, you know, if you're dealing with a quadratic specifically, like we are in this case, the approach may be a little bit different than trying to find, you know, a cubic or any other type of polynomial function equaling 0 like this. But when you have a quadratic specifically, which is anything that is in the form ax squared plus bx plus c, in other words, you have an x squared term, or whatever your variable is, your variable squared term, and then an x term, and then a constant term. Whenever you have these three terms, that makes it a quadratic. You can use the quadratic equation. So the quadratic equation just tells us that if you have a quadratic, which we do here, and it's equal to 0, and you're trying to figure out what x values solve that equation, you can use the quadratic equation, which just says that those x values are going to be x equals, and there's a little song that kind of goes along with this. That's how I always remember it, me personally. You can kind of sing this to the tune of Pop Goes the Weasel. So this is how I always remembered it. The opposite of lowercase b plus or minus the square root of b squared minus 4ac all over 2a. And I'll go through that. I know that was kind of fast. We'll come back to that. But that's kind of the song that I like to use to remember it. So it just goes the opposite of lowercase b, so negative b, plus or minus the square root of b squared minus 4ac all over 2a. So that is kind of the song. If it kind of helps you to have that song, that always has made this formula a lot easier for me to memorize. Thank you, Miss Kevin, my 7th grade teacher, taught me that one. But yeah, so basically we have x equaling, now where the b, the a, and the c come from are just the coefficients of your x squared, your x term, and your constant term. So exactly like what I have here. Your a is just the coefficient of your x squared term. So in this case, we don't have a coefficient. That basically implies that your a is 1. Our b is the number that goes with our x term. And then our c is the constant number that's all by itself. So if these three terms were in a different order, like let's say we had 25 plus x squared plus 10x, you want to be careful here because you still would treat 1 as your a, 10 as your b, and 25 as your c. So it's not important what order they are in the equation. What's important is what coefficient goes with the x squared, the x, and then the constant number all by itself. So that's really all it comes down to. So let's go ahead and just kind of plug these things in here. So 10 is b, so we're going to have negative 10 plus or minus the square root of b squared, so 10 squared minus 4 times a, which is 1, times c, which is 25. And then make sure this is all within the square root here. So you need to make sure that all these terms right here are all inside the square root. And then that's all going to be over 2a. So 2 times your coefficient 1, 2 times 1. Okay. And then you can pretty much just simplify this. So from there, you're just going to go x equals -10. You pretty much want to start with simplifying what's inside the square root here. So you're going to get 10 squared is 100. So the square root of 100 minus 4 times 1 times 25 is minus 100 all over 2. 2 times 1 is just 2. So we'll simplify that to a 2 right there. Okay. Now 100 minus 100 is 0. So inside the square root, we're going to have 0. So that just tells us that we have -10 plus or minus the square root of 0. Well, the square root of 0 is just 0. So that's just going to be -10 plus or minus 0 all over 2. Well, plus 0 or minus 0 still just leaves you with -10. So you're going to have just -10 on the numerator over 2, which is -5. So this is a unique kind of situation where whenever you get 0 inside the square root like this, that basically tells you that your quadratic only has one root, because you're going to end up with something plus 0, something minus 0, which just gives you the same number. That you're not like adding a number or subtracting a number, you just have one result. So in this case, x equals -5 is going to be our only real root of this equation, because it's the only number that we got out of this quadratic equation. Now, really what that tells you is that this quadratic that we had here, this equation, the vertex is on the x-axis. If the vertex of a quadratic is on the x-axis, that tells you that that one vertex is the only point that hits the x-axis. So there's not going to be two roots when that happens. There's only going to be the one, which is the vertex. So that's the 0 of that polynomial function. If you are getting some value out of this video so far, do me a huge favor, hit that like button down below, hit that subscribe button and that bell icon while you're down there too. I have a live stream every Monday night, 5 o'clock Pacific time. We do still have one more problem to get into here, where I'll show you kind of one more approach that we can take to solve these. I'm not seeing any questions in the live chat, so we'll keep chugging along here. But yeah, if you wouldn't mind, if you are getting some value out of this video, just go drop a like down below, please. It's a huge help to my channel, so I can keep making more videos like this. We can keep growing the Jake's Math Lessons community and getting these videos out in front of more people. So thank you for doing that. All right, so again, find all the real zeros of the polynomial function. F of x equals 1/3 x squared plus 1/3 x minus 2/3. So again, as always, when you're trying to find the zeros of a polynomial function, all that really means is take your function, set it equal to 0. Now, the kind of hard part from there usually is kind of figuring out what x values actually solve this equation. So we can use the quadratic equation if we wanted to, just like we did in the last example, where basically we would have a equals 1/3, b equals 1/3, c equals -2/3, and just plug it into the quadratic equation. But what I'm going to do here instead is show you an example of factoring this. Since the first example of factoring we did was a very specific type where we could use difference of squares, this one is not going to be like that, because we have 3 terms. We don't just have the difference of 2 square terms like we did before. We're going to have to actually factor this. Now, the reason I want to show you how to factor this is because, you know, sometimes a quadratic like this can look a little daunting when you have fractional coefficients like this. But there's one key thing that I really want to point out here. Whenever you're factoring a quadratic in general, the first step you always want to look for is, do all of your terms have a greatest common factor? If they do, you want to start by factoring that out, because that's going to make your factoring a lot easier from there. So notice 1/3 x squared, 1/3 x minus 2/3. There is a greatest common factor that all 3 of these things are divisible by, and that is 1/3. So we can actually factor out 1/3 from every single one of these 3 terms, and then hopefully we'll have something that's a little bit easier to factor left over at that point. So we can go ahead and do that. We'll pull out the 1/3. If we divide this first term by 1/3, 1/3 x squared divided by 1/3 is just going to leave us with x squared. 1/3 x divided by 1/3 is just going to leave us with an x. And then negative 2/3 divided by 1/3, if we pull that 1/3 out, that's just going to leave us with the negative 2. So basically, this now is something that probably looks a little bit more realistic to be able to factor this without, having some weird factors in there. Really, whenever you have your coefficient of your x squared term just being 1, or in other words, you don't have a coefficient, the 1 is just kind of implied, you really just have to think about a list of numbers that will multiply to whatever this number is here and add to whatever your coefficient of your x term is. If there's no coefficient, it's implied that it is 1. So we need two numbers that multiply to negative 2 and add to positive 1. So what might those different factors be? Really, you can just take this number that they have to multiply to and think about what are the factors of that number. In this case, the factors of negative 2, we could either have negative 1 times 2 or negative 2 times positive 1. Those would multiply to give us negative 2. Well, if we need them to add to positive 1, we can see these first two here, positive 2 and negative 1 will add to positive 1. Negative 2 and positive 1 will add to negative 1. So since this one adds to positive 1, like what we wanted, we're going to want to use these two factors here. So negative 1 and positive 2 are the numbers that we want. Whoops. Negative 1 and positive 2. So basically what that tells us is we know we will have x minus 1 as one of our factors and x plus 2 as our other factor. And then we still need to keep this 1/3 out front if we're going to make sure to factor that correctly. And that's all equal to 0. So basically we could factor out this x squared plus x minus 2 into x minus 1 times x plus 2. If you ever want to double check, make sure that you did that right, you could always FOIL this out and see if you end up back where you started. In this case, we should end up with a 2x, a positive 2x, and then a minus x, which would simplify down into plus 1x. And then negative 1 times positive 2 gives us negative 2. So that should FOIL back if we were to kind of double check our work by going backwards again. But I'll kind of move on from there. So like I said before, if you ever have multiple things being multiplied together like this, and you know that the product of all three of these terms, 1/3, x minus 1, x plus 2, the product of these three things has to be 0. That means that'll happen whenever one of those three things is 0. It doesn't matter what the other two things are, as long as one of them is 0. So that kind of gives us three separate equations that we can set up and see if there are any x values that are a solution to each of those three parts. So we would have 1/3 equals 0, which I know doesn't make any sense. Don't worry, I'll come back to that in just a sec. X minus 1 equals 0, and x plus 2 equals 0. So again, any x value that is a solution to any of these three equations will be a factor, or I'm sorry, a 0 of our original function. So 1/3 equals 0, that never happens, right? 1/3 does not equal 0. There's no x's in here, so it's not like it's dependent on whatever your x value is. There just simply is no solution to this equation. So that won't contribute anything useful for us. 1/3 does not equal 0 ever. Then we can solve this equation by just simply adding 1 to both sides. So that'll cancel the minus 1 over here, giving us x equals 1. Then we can solve this equation by subtracting 2 from both sides. So that'll cancel with the plus 2, giving us x equals negative 2. So x equals negative 2 and x equals 1 are the zeros of our original polynomial function because they solve this equation in its factored out form. And, interesting thing, if we were to take 1 and negative 2 and plug them back into our full function, we should get 0. That's one way you can kind of confirm that your solution actually makes sense. But yeah, if you did get some value out of this video, like I said, do me a favor, hit that like button down below. It's a huge help to me. Go ahead and subscribe while you're down there too, and hit that bell icon so you're notified when I go live each week. I come out with a bunch of other videos. I'm working on a series right now that I think is pretty fun about using math to play daily fantasy sports, just something that's kind of fun, like application, real world application of math, just to hopefully get pre-calc and calc students kind of excited about applications of what they're learning and how to kind of build on that to further your own knowledge and do your own kind of experiments with math. So I think if that sounds something you might find interesting, hit that subscribe button. Be sure to keep checking back for my videos. Not seeing any questions in the live chat, so we'll go ahead and wrap things up there. And we'll be back next week, Monday, 5 o'clock Pacific time, 8 o'clock Eastern for another live stream. So if you have any questions, feel free to join us there and get your questions answered live. Anyway, have a good rest of your week and see you next time.